Hello viewers, hello fans. Welcome once more to Data Analysis in SPSS 22. In today's tutorial, we are looking at normality test in SPSS and interpretation in a thesis or project. Normality test in SPSS and its interpretation in a thesis or project. Note, we are using the same data, that is IRIS data project 1 throughout this analysis. IRIS data project 1 throughout this analysis, which can be downloaded in the link below this video or the previous videos on demographic analysis, computing variables, and reliability statistics from the site. Stay tuned. Please leave your likes and comments. Don't forget to subscribe and share. Watch the video to the end and thank you. First of all, let us start by looking at, in brief, in a minute, what normality is all about. So, normality assessment is performed to know if the data is normally distributed or not normally distributed, in order to know if one should apply parametric test, that is for normally distributed data, or non-parametric test for data that is not normally distributed. Equally, it is an assessment of the normality of data, which is a prerequisite for many statistical tests, because normal data is an underlying assumption in parametric testing. There are two main methods of assessing normality, which are graphically and numerically. Two well-known tests for normality are the Kolmogorov-Smirnov test and the Shapiro-Wilk test. The Shapiro-Wilk test is more appropriate, that is, it's more accurate, especially for small data with samples of size less than 50, but can also handle sizes as large as 2,000. Okay, so these are Kolmogorov-Smirnov test as well as the Shapiro-Wilk test are numerical tests. We can equally look at tests graphically. Equally, another numerical test is look at the skewness as. So, if you need to use skewness and kurtosis values to determine normality, which is also very important, this is another numerical test. You can equally use skewness and kurtosis, or use the Kolmogorov-Smirnov test and the Shapiro-Wilk test. Normally, you can see most of these tests are always in pairs, okay? If you are using skewness and kurtosis to describe normality, you work with just those values within the particular range, or you can use the Kolmogorov and Smirnov and Shapiro-Wilk test. Okay, but this one is more accurate. The second one is more accurate. Now let's look at the sample data analysis in SPSS. And note, we are using this data IRIS data project 1. You can download it from the site and look at our previous videos on data analysis for thesis or project, step by step. Now we are taking a model analysis. So the data we are working with in this analysis was from the questionnaire which we discussed earlier on, measuring the relationship between service quality and client satisfaction in Casablanca commercial banks. So at this level, we want to get the normality of this item, of this variable, service quality, as well as the normality of client satisfaction, so we can know if we should apply parametric test or non-parametric test, okay? So in doing our normality test, in carrying out a normality test, the first thing we will do is to give an intro. We give an introduction, okay? So for example, here we have normality assessment checks if the data is normally distributed or not, in order to know if parametric, that is for normally distributed data, or non-parametric test, that is for non-normally distributed data, should be applied. The Kolmogorov, Smirnov, and Shapiro-Wilk tests are used in this study. If the significance value of the Shapiro-Wilk test is greater than 0.05, that means you're using 95%, the data is normally distributed. If it is below 0.05, then the data is significantly different or significantly deviates from a normal distribution, which means that if this value is less than 0.05, it is not normal. If it is greater, it is normal. Okay. So what's the next thing we have to do now? We have to give a title for the table of the normality. Give a table title. So table 4.3 normality. Note that the previous table we gave 4.2 for reliability. Now the next thing we have to do, we have to go now to our SPSS software, where we are now going to run the test. We now run the test, then we see what happens. So let us run the test and then we get back and put the values here. So normally when we run the test, these are the values we are going to have. Okay, so let's run the test and see. So we are now at our SPSS table. For us to do normality, we go to Analyze, Descriptive Statistics, and we go to Explore. Analyze, Descriptive Statistics, and then Explore. Now at this point, you can see that these things are already here. Let me bring them back so that it should be normal. So I want to do a normality test on the two variables which we computed in the previous video. That is how to compute a variable. So you can look at the two previous videos before this one. So what are the variables I want to compute the normality? Service quality and client satisfaction. In further tutorials, we'll show you how we can factor out this list, maybe for gender and male, to see if that for gender is for male is normal and that for female is not, or whatever. But here, we just want to do a simple analysis. Our cases are direct. So we put all of them inside this dependent list. Okay? Now we have to check. We make sure that we are going to work with both statistics and plots. We need both statistics and plots. If I take just statistics, I might not have the normality test. So we check under statistics, we make sure that it is descriptive. You are at the 95% level, you leave everything as it is. And then for plots, we have to check this box. Normality plot with text. If you don't check this box, we might not have that table. So we must make sure it is checked. You can uncheck this one, no problem. We continue. Then for options, we leave it exactly as it is, as well as bootstrap. So we take OK. So this is what displays now. With that single command, we can see that here they have given us a descriptive of the normality. Here on this table, we have the skewness. You have the skewness for the variable, as well as what? As well as kurtosis. So somebody wants to report using skewness or kurtosis may come to this same table. It gives us all the analysis of what we need. Okay? The first table gives us the question mark. That's not our interest. Our interest is this one here, where we have test of normality. This is our interest. We just need to copy this table and paste. Like I said before, it's not going to copy tables and paste, but this one is a special case because you just need the data exactly as it is. So I'm just going to copy this table, and then I'm going to paste in my work, and then I'll continue. Here we can see that for service quality, the value of the significance is 0.002, which is far less than the 0.05 value. Okay, so in this case, what do we say? We see that this is significantly different, because this value is significantly different from the normal distribution, which means that service quality is not normal. As well as client satisfaction, the value of 0.000 is less than 0.05, which means that these two variables are what? They are different from the normal distribution, which means they are not normal. If you look at the Kolmogorov-Smirnov as well, the values also show the same thing. Look at the significance. This one shows that this is 0.05, and this one means it's higher than 0.05, right? Which means that it is normal. But this one is a more accurate test, so we consider the Shapiro wheel. Okay, when this happens, we consider the Shapiro wheel. The second one, the cases match, because this 0.012 is less than 0.05. Okay, so we are going to consider the Shapiro wheel. So whenever this happens, this is what you do. So at this point now, we have to paste that our table here, which we just copied from SPSS, and this is the table which I have modified a bit. That's the outline. Now on this table, we have already discussed if the data is significantly different or the same as normal distribution. So what are the comments we are going to put on the table? Next thing is commenting. So here, the Kolmogorov, Smirnov, and Shapiro-Wilk statistics in table 4.3 above revealed that the data is significantly different or significantly deviates from a normal distribution, since the significant values were below 0 0.05. Therefore, known parametric test will be applied. Known parametric test will be applied because the data is significantly different from the normal distribution, which means it's not normally distributed. Thank you guys so much. Please make sure that you leave your comments, you share this video. In the next step, we're looking at descriptive statistics, and as well, we are going to continue with the regression analysis and help you on how to choose your test. If you have issues with tests or you like to hire a writer or whatever, you can always contact us. Please subscribe and share, and bye-bye.